Hello, Algebra 1. I'm here to help you out with the extra practice I'd promised that I would give you for the final. If you've gone through all the other reviews with me, then this extra practice is just a little bit more insurance to make sure that you're very confident in your ability to take my final. When you go through this, make sure you actually do this final yourself first and watch this video after. If you're ever confused about a problem, skip ahead through the video, fast forward, skip around, and find the question you're actually curious about. But do not watch this before you even try it. Actually try it and see how much you can remember. That's the best way to study and remember what you need to do during the final. That being said, if you're ready to watch this video, I'm starting now on number 1. So we have 3x y squared times 4x to the negative 4 times y to the 0 power. Everything in this section is just exponent rules because, one, I hope you're using your star chart so that you could remember when do I multiply, when do I add, when do I subtract, when do I divide exponents. So in this case, we have this set times this set, and even though there's only one dot for multiplication shown, we know that if we have coefficients and letters next to each other, everything is really being multiplied. And we know multiplication order doesn't matter. So if you want to, you could write everything in the proper order. So like, let's say I want to do 3 times 4 first. Well, I'm going to do 3 times 4, and that's going to give me 12. And let's say I go for the x's next. Couple of things I see is I have an x and an x. Great. I know that if there is no exponent written, this is x to the first power. Now I could say x to the first power times x to the negative 4. We add those exponents, and I would end up with 1 minus 4, which is negative 3. We could do that, or if you prefer, we could go ahead and jump to the fact that this is a negative exponent. And every time we see a negative exponent, it follows the negative exponent rule on your star chart, which is that any negative exponent will flip the number and place it as a positive number below. So if I want to, I could say x to the first power stays where it is, but it's also times x to the positive fourth power now if I flip this negative 4. And no matter what, we're going to end up with negative 3 because 1 minus 4 is still 3. But let's say I just add together. 1 minus 4 is negative 3. I get x to the negative third, and I'm going to flip that later. Y squared times y to the 0. Well, y to the 0 is great because anything to the 0 power equals 1. So y squared times 1 is just y squared. Well, I still need to fix this negative 3 exponent because we never leave negative exponents in our final answer. And you see in the answer choices, there is no negative exponent. So we're going to take this negative 3 and again flip it and make the 3 positive. So 12x y squared. X is going from the numerator down to the denominator, and we get x to the positive 3. So our final answer should be 12x, actually there shouldn't be an x left on top anymore. Just 12y squared divided by x cubed. Okay, next question, 2. Let's go ahead and say multiplication order genuinely doesn't matter, and maybe I don't want to do the numbers first. And I want to do, I don't know, a first. A to the 0 power I know is gone. It's 1, so I'm left with a to the 4th. So I'm going to have a to the 4th somewhere in this answer. So the a's are done. And let's say I do the b's next. B to the first power times b to the 4th power. I add those exponents, and I get b to the 5th power. And finally, 2 times 3 is 6. And for whatever reason, they answer choices decided to write B in front of A, which is not alphabetical, but is the same because in multiplication, order again doesn't matter. 3. We have an exponent on the outside of an exponent with parentheses. We are not going to add these, we are going to multiply. And because 2 is on the outside of multiple things, a 4, an x, and a y, this square is going to square the y to the 0, it's going to square the x, and it's going to square the 4. It's a lot like distribution. So this is ultimately going to be 4 squared times x squared times y to the 0 squared. But y to the 0 is just 1, so 1 squared is 1 times 1 is just 1. And we never really write 1, so it's gone, which is nice. We're left with 4 squared times x squared. X squared because, well, x to the first power squared is just x squared. 4 squared, I'll give you a second. What is 4 squared? I sure hope you didn't say 8, because 4 squared is 4 times 4, which is 16. So, 16x squared, final answer. 4. Again, we have an exponent on the outside of multiple things on the inside. So this exponent is going to go here, and technically it could go here, if you want to think about it. That negative in front of the x, you could consider it a separate coefficient, -1. We're going to see that it's going to turn out the same no matter what. So that is -1 to the negative first power times x to the -3 to the negative first power times y to the 0 to the negative first power. The -1 goes to everything. Well, this one is very nice because -1 to the negative first power still follows the negative exponent rule. This becomes 1 over -1 to the positive first power times, well, 1 divided by -1 is just -1. So in essence, it didn't even change. You can't really mess with -1 that much. And then x to the -3 times -1. Negative times negative is positive, so x cubed. And then y to the 0 times -1. 0 times anything is 0. Y to the 0 is 1. We don't usually write the 1, so we're left with -1 times x cubed, which is usually just written as -x cubed. Five, division. So we are no longer adding exponents, and there's no power to a power, there's no parentheses, so we are not multiplying either. This is subtracting exponents. So for coefficients, 3 divided by 3 is 1. So we're going to have a 1 somewhere in there, or it's canceled and gone. We could imagine that. A cubed. A's go with the A's. 3 minus 2, always top minus bottom. We're left with a to the first power on top, because the largest exponent is on top. And then finally, we're left with a single b that has nothing to divide by. So a over b is our final answer. Number 6. Let me clear some space. -4 divided by 4 cancels to 1. We don't write times 1, so it's gone. X to the -4 times x cubed, or divided by x cubed. We could do this just the way it looks and say top minus bottom, -4 minus 3 is -7, and we end up with a -7. Or if we choose, I think it's easier this way, go ahead and flip the -4. It'll just make our lives easier to see where it's going to end up. So -4 as the exponent is going to come down, and we're going to have x to the 4th, and then we still have the x cubed below. Y to the -3, conversely, will go to the top, and we have y cubed, this one, times this extra y cubed that we're flipping to the top. Now it's easier to see where things are going to end up. 3 times 3, not 3 times 3, 3 plus 3. We're adding these exponents. 3 plus 3 is 6. 4 plus 3 is 7. And we have our answer. Y to the 6 over x to the 7th power. Okay? So these are exponent rules. Highly recommend while you take the final, you use your star chart while you're going through any exponent problem so that you know for a fact, should I flip this number? Should I multiply these numbers? Should I add these numbers? Should I subtract these numbers? Okay. Slope-intercept form of each equation. This is just saying we need to write these in the form y equals mx plus b, which is in essence just saying, can I get y all by itself if they give me 2x minus 3y equals -6? Well, sure I can. And my recommendation, anytime we're solving for something, trying to get something by itself, we do the reverse of PEMDAS, which is sad. Meep. Add and subtract what you can first, then divide or multiply what you can first, and then usually there's no exponent or parentheses in Algebra 1, so by that point you've probably solved for it. Let me explain. I take 2x minus 3y equals negative 6, and I do sad meep. Can I add or subtract something to the other side to get this term, y, all by itself? Well, sure. The opposite of positive 2x is minus 2x. So, we've got rid of the SA. We've done subtraction or addition. So, we have negative 3y equals, well, which should I write first? These aren't like terms, so I can't put them together. And I want it to look like mx plus b, so let's write the minus 2x first. And then the minus 6. Okay, we've done subtraction. Got that out of the way. Next thing is, can we divide? I need to get this y by itself, so let's divide by negative 3. Now, when we divide both sides of the equation, or multiply, or add, we are doing it to the entire equation. So in this case, I'm going to divide everything by negative 3. And make sure it's negative, because the sign matters. Negative 3 divided by negative 3 is 1. Negative 2 divided by negative 3. Negative is positive. I'm going to leave this as 2/3 x, because now I know rise over run. I'm rising 2 and running 3. This is a great way to write a slope, rather than turning into a decimal. And then finally, negative again becomes positive, and 6 divided by 3 is 2. We have the slope-intercept form. Y equals 2/3 x plus 2. Looks like our answer is D. Number 8, same thing. You add or subtract what you can first. So in this case, we do not need this 5x on this side of the equal sign. We want it on the other side. So we're going to get negative 2y equals negative 5x first, so it looks like mx plus b, minus 12. Divide both sides by negative 2. Divide everything by negative 2. And we'll get y equals positive 5/2 x plus 6. C. Next, simplifying square roots requires us not to plug this into the calculator and get a decimal, because we could see what this equals as a decimal and then plug every single one of these in and see which one matches up. That's not very useful later on in your life when you don't have a multiple choice test. So what you can do is, if there is a perfect square within the square root, take it out. What does that mean? We need to know our perfect squares. So the square root of 4 is 2. That's the first perfect square. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. All this means is, why is the square root of 4 2? Because 2 times 2 is 4. Why is the square root of 9 3? Because 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, and so on and so on. If it contains a perfect square, we take it out. And if it doesn't, you just leave it under the radical, the square root, and you leave it. So you notice all these answer choices, they're left with some kind of square root left behind that cannot simplify further. Which means, square root of 18, there is a perfect square inside of 18. It's 9. I could break up 18 into the square root of 9 times 2. And I know the square root of 9, it's 3. So it comes out. And what am I left behind with? That 2. There is no square root of 2 that I could write pretty, so I'm left with negative 3 times 3 is negative 9 rad 2, or square root of 2. And that's as simplified as this answer can possibly get. A. So having your multiplication tables memorized helps. Knowing your perfect squares helps. If you're ever seeing a square root problem, just really quickly in your head, look at the number that you're trying to reduce, like 18 or maybe 72, and just quickly go, well, does it contain 2 times 2? Does it contain 3 times 3, or 4 times 4, or 5 times 5? If it doesn't, then maybe it can't be simplified. But we just saw square root of 18 is the same thing as the square root of 9 times 2. And the square root of 9 is 3. So I'm left with 3 rad 2. But we had a negative 2 still being multiplied out front. So negative 6 rad 2. And that's spelled negative 6 radical 2. Or, long way of saying it is negative 6 times the square root of 2. Both are acceptable ways of saying it. Alright, let's clean this up and get you guys started on some factoring practice. For intents and purposes, I'm going to be using mostly FOIL. If you prefer the box method, please use it. There is no difference between using the box and FOIL, but if you prefer it and it looks nicer than you, just follow along and you'll see the same numbers being multiplied. So negative 5 times 6n minus 3 plus 6. Simplify just means there are things in this that can be put together. And anytime I see a number outside of a parentheses, I think distribution. So negative 5 times 6n is negative 30n. Negative 5 times negative 3 is positive 15. Plus 6. And then I have like terms. 15 can combine with 6. And minus 30n is stuck by itself. 15 plus 6 is 21. And we are done. 12. Again, distribution. It looks scary, it's got fractions, don't let it freak you out. The 2 will go to the x. The 2 will go to the 2 sevenths. So, 2 times x is 2x. 2 times 2 sevenths is 4 sevenths. And we have a minus 2/3 x that's still out front. What can go together? The minus 2/3 x plus 2x. Now you could just plug minus 2/3 plus 2 in your calculator. You're going to find out what it is. But I'll show you how to combine fractions. You just need a common denominator. So negative 2/3, let's leave it the way it is. Could I write 2 as some kind of third? Well, 2 is the same thing as 6 divided by 3, and now it's written in third form. And now I just combine these. Negative 2 plus 6 is 4. And now I have 4/3. So I end up with 4/3 x plus 4 sevenths is my final answer. Okay, 13 and 14 are just recognizing when you need to distribute something. When does it matter to distribute this negative to the parentheses? And why doesn't it matter to distribute the negative 1 to all of these? Well, 1 times 3m cubed is just 3m cubed. 1 times 2m to the 4th is just 2m to the 4th. So the 1 doesn't matter. You need to recognize that in this first set of parentheses, the parentheses mean nothing, and they don't need to be there. Nothing is being multiplied because it's just 1 out front. This negative, however, we are changing the signs of everything on the inside. We call this distributing the negative. So positive 4m cubed becomes negative 4m cubed. Negative 4m squared becomes positive 4m squared. And negative 5m fourth becomes positive 5m to the 4th. Now we just combine like terms. We gotta look at their exponents to see what goes with what. 3m cubed goes with minus 4m cubed. 2m to the 4th goes with 5m to the 4th. And it looks like 4m squared is all by itself. And looking at the answer choices, it looks like we're ordering them in standard form, from biggest exponent down to the smallest. So we're going to get 2m to the 4th plus 5m to the 4th is 7m to the 4th. 3m cubed minus 4m cubed is negative m cubed. And finally, plus 4m squared, all by itself. And we have, looks like B. No, that's not right. Something wrong with this one. 7m to the 4th minus m cubed plus 4m squared. There we go. Gotta be careful. 14, much the same, except there is no distributing the negative. You distribute a positive 1, nothing changes. You distribute a positive 1, nothing changes. These parentheses do not need to be there. So we have 3 minus 2b squared plus 3b to the 4th plus 2b squared minus 3. we are just adding and subtracting. So let's see. The squares go together. The 3's go together. And the 3b to the 4th is left alone. But 3 minus 3 is 0. 2b squared minus 2b squared is 0. We're left with this 3b to the 4th. Okay, this is the concept of factoring difference of two squares, which is on your star chart. I didn't go into too much depth because if you recognize that if this is in standard form, ax squared plus bx plus c, then we'll know b is 0. There is no x in between x squared and 4. C is negative 4, a is 1. So if you want to solve it like a times c is negative 4, 1 times negative 4, and b is 0 because there is no x, then we're going to see it's 2 minus 2. That's one way you can always solve this. But if you look on your star chart, we'll see a squared minus b squared. If it's ever in this form where you recognize that we have perfect squares, like 4. 4 is a perfect square, it's 2 times 2. It's going to turn into whatever a is, whatever b is, whatever a is, whatever b is, and then minus and plus. So let's say I recognize this as a difference of two squares. Then that's x squared minus 4, but 4 is 2 squared. So what's a? A is x, and b is 2. So I could say, factor this real quickly as a shortcut. A is x, b is 2. A is x, b is 2. And then make one of them minus, one of them plus. And that's the answer. Usually that makes your life easier. So again, x squared minus 25. What do I recognize this? 25 is a perfect square. The square root of 25 is 5, because 5 times 5 is 25. So this, again, is a difference of two squares. You could do cross method, negative multiplies to negative 25, adds to 0, or recognize right away. A is x, b is 5, because 5 squared is 25, and make one of them plus, one of them minus, in any order. Because I could write it as x minus 5, x plus 5, and these are the same as well. And no matter what, we get d. So recognizing difference of two squares, recognizing a perfect square makes your life a lot faster and easier. Okay, 17. We're getting on to FOIL and box method. I think I'm going to show box method for one of these and FOIL for the other. So whenever we're multiplying binomials, that means two terms, 1, 2, 1, 2. Then generally we use the acronym FOIL, first, outer, inner, last, or the box method, the punnet-looking square thing, just to make our lives easier and so that we don't forget what has to multiply. So first one, I'll do box method. 2x positive 5, 8x minus 6. And then multiply everything on the inside. 2x times 8x is 16x squared. 5 times 8x is 40x. 2x times negative 6 is negative 12x. And 5 times negative 6 is negative 30. And we do this mostly because Punnett squares are easy to understand because you've taken biology, and the like terms are always in the diagonals. So 40 minus 12. Well, let's see. 40 minus 10 is 30. 30 minus 2 is 28. So we got 28x in the middle, 16x squared out front, and a minus 30 in the back. 16x squared, my bad. So our answer is B. 18. This one I'm going to do FOIL, just because I'll show you why if you do it often enough, you start doing it in your head, and then you don't really need to write down a box, and it makes you faster. But I will never, ever fault you for using the box method. So in my head, without writing it down, I usually think, well, first times first is 3p times 4p, 12p squared. First outer, so 3p times negative 3 is negative 9p. Inner, negative 4 times 4p is negative 16p. And finally last, Negative 4 times negative 3 is positive 12. So I end up just multiplying the outside and the insides in my head. And if I ever have to, I'll carefully add the inside and outsides together. Negative 9p minus 16p is negative 25p. Okay, factor each completely. Again, you just need to know what A, B, and C are. The first step is always make sure it's in standard form. All of these are. That just means is the square first, is the single variable second, so x squared, x, and then finally c. So ax squared plus bx plus c, so that you could tell what's a, what's b, what's c. So in this case, always, 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 they multiply to a times c, but add to b. So in this case, a is 1, because there is no number in front of b squared. C is negative 3. 1 times negative 3 is negative 3. And b is negative 2. So let's see. Two numbers that multiply to negative 3 but add to negative 2. I'm thinking negative 3 and positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. And if a is equal to 1, we just write the variable twice. In this case, it's b. Normally, it's x. Doesn't really make a difference. Then we write our numbers, minus 3 and positive 1. And the order of these two factors does not matter. So let's see if it lines up with anything. Nope, nope. There it is. B plus 1, b minus 3. Even though it's not in the same order I wrote mine, multiplication order doesn't matter. So that is the answer. Okay, how about 20? Is it in standard form? Absolutely. Does it have a GCF? I think so. And the reason why is the first coefficient's 2. 34 is an even number and 144 is an even number. Everything's divisible by 2. If we can divide something and pull out a GCF, reverse distribution, we should. So we're pulling out a 2 from each of these. So what do we get? 2 out front. V squared plus what's 34 divided by 2? Real fast in my head. Nope, can't do it. 34 divided by 2 is 17. Yeah, I should have been able to do that. I'm getting rusty. 144 divided by 2 is 72. So, we've made our lives easier because now I have a new A, B, and C. A is 1, B is 17, C is 72. And if A is 1, we could skip ahead and not do any shortcut or weird thing and just write the variable and the variable. That's always what we want to have happen. The 2 just tags along for the ride. So we're going to get 2 times 2 extra parentheses. So 2 numbers that multiply to 72, but add to 17. I bet that's 9 and 8. 9 times 8, 9 plus 8. So V plus 9, V plus 8 is our answer. C. 21. We are looking at p squared plus 7p minus 30. No GCF because a is 1. So 2 numbers that multiply at negative 30 but add to 7. Let's see, 6 times 5 isn't good. 3 times 10, 3 and 10 usually make a 7, so let's see. What do I want to make negative? Probably the 3. 10 minus 3 is 7. So I got p minus 3, p plus 10, b. Okay, last but not least, back page is quadratics. So this is the section where we need to know the most important thing. What is another word for solutions, zeros, x-intercepts, roots? They're all the same thing. Solutions are x-intercepts. In your calculator, they're called zeros. You might also see them as roots. And they all mean the same thing. They're all just x-intercepts. So step 1 on your chart list is, if you can, Set everything to 0. That's always step 1. So this 7p is in the wrong place. Ideally, you want to leave whatever your squared thing is, p squared, b squared, x squared, you want to leave it positive. So I never want to subtract that over to the other side. If you can, leave this positive. So minus 7p. And we get p squared minus 7p plus 10 equals 0. And now we have a, which is 1, b is negative 7, c is 10. And we got multiplies to 10 and adds to negative 7. 5 and 2? Yeah. Make them both negative, because negative times negative is positive, and negative 5 minus 2 is negative 7. And we got p minus 5, p minus 2, still equal to 0. And by the zero product property, either this thing equals 0 or this thing equals 0. So when p minus 5 equals 0, or when p minus 2 equals 0, p would equal 5, and p will equal 2. Because 5 minus 5 is 0, 2 minus 2 is also 0. So our two solutions are two x-intercepts, because these are not coordinates. This is not x comma y. That would require parentheses. These are brackets, which means how many x's do I have as solutions? 2 of them. One of them is 5, one of them is 2. The answer is C. 23. Again, set everything to 0, so add the 12 over. X squared plus 7x plus 12 equals 0. Two numbers that multiply to 12 but add to 7, 3, and 4. X plus 3, x plus 4 equals 0. So when x plus 3 equals 0, x equals negative 3. When x plus 4 equals 0, x equals negative 4. And our two solutions are A. 24. We need to graph these. All of these are in vertex form. F of x equals a times x minus h squared plus k. And we know h moves things left and right, k moves things up and down, and a either reflects if it's negative or stretches or shrinks. So we have right 4, because the inside lies. Up 1, because the outside doesn't lie. And 3 is greater than 1, so stretch. It's getting taller, skinnier, narrower. So, we need to know what the parent function is, so that we can compare it. Y equals x squared is the most basic parent quadratic function. And we are moving it right 4, up 1, and stretching it. So right 4, up 1, would place my vertex right there. It's positive, so it's facing up, and it should be skinnier. I don't really care how you sketch it, as long as it looks skinnier than normal. 25. Inside lies, so right 2. Up 1. 1/2 is less than 1, so wider. We are compressing this, making it fatter. So right 2, up 1 would place my vertex here. It's positive, so it's facing up, and just sketch it wider. Okay, that's quadratics with the parent function y equals x squared. Quadratics. 26. Y equals 3 times 1/2 to the x. These are exponentials. So a couple things we need to know. We need to know what A is, what B is. We need to know whether it's growth or decay. We need to know its y-intercept. So if A is 3, its y-intercept is 3. A is always the initial value. And it says 1/2. 1/2 is less than 1, so that would be 3 times 1/2 raised to the first power, to the second power, to the third power, to the fourth power, and so on. I'm taking half and half and half and half. It's decaying. This is decay. So you could get a bunch of points and just check to make it super accurate, but if you graph it, you're going to see which one looks right on a multiple choice test anyways. So for me, as long as you draw it like a decay function, I'm happy. So what do I know about this? It goes up forever and to the left forever. It goes to the right forever, but not down forever. I sketched it poorly, but it has an asymptote. An asymptote is a line that we approach but never ever touch. Gets super close, crazy close, but never zero. So this is the line, the x-axis, sorry. Y equals 0. The horizontal asymptote. So 27. A is 4, B is 2. A means its y-intercept is at 4. A b value of 2 means growth, times 2, times 2, times 2. And it's still going to have an asymptote at y equals 0. That's good enough for me. On the back, I hope you already probably noticed, we had the answers. And I'm done. Good luck on the final. Good luck on all your finals. And please, as always, ask me for questions if you need help studying.